Rehabilitating the nation's aging transportation infrastructure is the premier challenge today facing transportation agencies across the nation. Meeting that challenge demands innovative research and the application of new transportation technologies that keep our roadways in good condition for years to come. For the Georgia Department of Transportation, the challenge of finding a cost-effective, durable, and efficient solution to replace the paved asphalt shoulders along Atlanta's I-285 perimeter was recently met with an innovative application of roller compacted concrete, or RCC. The Georgia DOT used RCC instead of asphalt or standard Portland cement concrete to replace nearly 35 lane miles of asphalt shoulder along Atlanta's Beltway, marking the first time the material has been used on a highway reconstruction job in the country. The existing asphalt shoulders along the heavily congested roadway were experiencing a shortened life cycle. Potholes at the edge of the existing PCC pavement, for example, required frequent maintenance.
Georgia DOT has been very successful with this pavement preservation program for several decades, something that we're very proud of. As traffic volumes and load limits increase, we need to utilize the most effective pavement treatments available that provide strength and durability to our highway system.
The strength and durability of RCC is well documented. RCC has been around since the 70s, providing a pavement solution for the large equipment and heavy loads found in the sorting yards of Canada's timber industry. Recent applications attesting to RCC's strength and durability include intermodal port facilities, military bases, and at auto manufacturing plants, including Honda Motors' 200-acre facility in Lincoln, Alabama, which is the largest RCC pavement project ever built.
RCC has the same durability characteristics as conventional concrete pavement. It uses all the same materials as conventional concrete pavement, with the exception that it uses less water, which enhances the durability characteristics.
The cost to place RCC are very similar to those to place asphalt concrete. The difference is the RCC can go down in one layer or one lift compared to the two lifts that the asphalt would be required for the 8-inch amount of thickness of the RCC.
The durability and condition of the pavements at Honda and other facilities after decades of continual use were just two reasons why the Georgia DOT elected to use RCC on its transportation project. The Georgia DOT's project included the replacement of the north and southbound shoulders of I-285 on Atlanta's west side, as well as selected PCC slab replacements on the main line throughout the 17.3-mile project area. To maximize production and minimize impact to the traveling public, the project was performed on weekends, beginning Friday night at 9 p.m. and continuing until 5 a.m. Mondays with a single lane closure. Milling out the old asphalt shoulder occurred at night and continued until about 5 a.m. on Saturday. With widths from 10 to 14 feet, the shoulders were constructed to allow for RCC depths of 6 inches south of I-20 and 8 inches north of I-20. At a nearby interchange, a portable continuous pug mill plant capable of producing RCC material at a rate of up to 250 cubic yards an hour was made ready. The proximity of the plant to the project, along with the RCC placement methods, provided significant benefits, allowing crews to construct between 1.5 and 2 miles of RCC shoulder each weekend. The RCC mix design was developed by A.G. Peltz of Birmingham, Alabama, in conjunction with CMS Labs of Locust Grove, Georgia. The Georgia DOT's Office of Materials and Research in Forest Park, Georgia, approved the RCC mix design for transportation projects. Comprised of a blend of densely graded fine and coarse aggregate with a nominal maximum size of 1/2 inch and a low water-cement ratio, RCC's mix design has zero slump. RCC's unique design properties allow the material to be easily hauled to the construction site in dump trucks. Placement of the new RCC shoulders began early Saturday mornings and wound down each Sunday to make the highway ready for Monday morning traffic. A material transfer vehicle was used to improve the paving speed and provide a continuous placement for a uniform and smooth pavement surface. A high-density paving machine with a dual tamping bar screed was used to place the RCC material and provide an initial density of at least 90% of the target density. In addition, the mix design allowed the material to be placed in single lifts from 5 to less than 10 inches thick. A significant feature of RCC is that it needs neither forms nor finishing, nor does it contain dowels or steel reinforcing. To achieve proper compaction and reduce the voids in the RCC mixture, a 10 to 12 ton dual steel drum vibratory roller and a combo roller with a rubber-coated drum were used immediately after placement. Within the first 2 hours of placement, early entry contraction joints were cut to match the adjacent mainline pavement using soft-cut saws. A white pigmented curing compound was applied by the paving contractor to retain the moisture required to build strength quickly. Once the RCC had completely cured, final joints were sawed and sealed, completing the process and providing a shoulder pavement that is expected to have long-term performance. Quality control and quality assurance are very important to ensure the long-term performance of the RCC pavement. Nuclear density tests were performed immediately after placement and compaction. The process required a 98% average of the modified Proctor density with no test below 95%. A modified Proctor density was determined using the design mix following AASHTO standards. With the special provision for RCC shoulder pavement in place, the Georgia DOT initiated a research project that addresses the construction issues, evaluates short and long-term performance, and examines the feasibility of RCC to other applications. Though the long-term durability and cost-effectiveness of RCC on the Atlanta perimeter won't be confirmed for some time, officials are pleased with the product so far.
The shoulders on I-285 were designed with a 20-year service life. The pavement that we place should easily meet or exceed those expectations with minimal maintenance.
So as you can see, with the use of RCC for shoulder replacement, we consider the application of this material as a practical paved shoulder alternative and a viable solution for pavement management well into the future.